Hello student, now this is the question number 2 and the subpart is the first question. Solve the following equation by the method of inversion. I had completed this first question, sub question, and solve all the examples by using the inversion method in a very simple language. I hope that you understood all the problems, whatever that I had explained. त्याचबरोबर मी अनअकॅडमीच्या प्लॅटफॉर्मवर 12वी मॅथमॅटिक्स 12th स्टँडर्ड मॅथमॅटिक्स M1 आणि M2 हे पूर्ण शिकवत आहे आणि त्याबरोबर सीईटी देखील शिकवत आहे. जर तुम्हाला त्याचं सबस्क्रिप्शन हवं असेल तर तुम्ही माझा प्रोमो कोड वापरू शकता आणि त्यामध्ये तुम्हाला तो डिस्काउंट मिळेल. या छोट्या व्हिडिओ नंतर अनअकॅडमीच्या काही स्लाइड्स, पॉवर पॉइंट स्लाइड्स तुम्हाला बघायला मिळतील आणि त्यानंतर मग आपलं व्हिडिओ लेक्चर चालू होईल. Unacademy Plus subscription MST CET 2021 Leaders Batch. Learn from the stalwarts of Saptarshi classes for MST CET. आणि या बॅचेस या 14th of December पासून चालू होत आहेत. तुम्ही तिथे एनरोल करू शकताय. नंतर Unacademy Plus. Okay, that is, are you a plus subscriber? जर तुम्ही प्लस सबस्क्रायबर असाल तर तुम्हाला हे सर्व खालचे बेनिफिट्स मिळतील यामध्ये आणि सर्व काही तुम्हाला एकाच याच्या खाली मिळेल सर्व. दॅट इज एव्हरीथिंग अंडर सिंगल प्लस सबस्क्रिप्शन घेतलं तर तुम्हाला हे सगळे बेनिफिट्स त्यामध्ये मिळतील. त्यानंतर अनअकॅडमी प्लस सबस्क्रिप्शन यामध्ये 12 महिन्याचा आणि 6 महिन्याचे 2 कोर्सेस त्यांनी वेगवेगळे आहेत ते आणि त्यामध्ये शिकवणारे हे सर्व एज्युकेटर्स आहेत. यात देखील तुम्ही प्रवेश घेऊ शकता. याचंही देखील सबस्क्रिप्शन तुम्ही घेऊ शकता. नंतर हे सर्व टॉप एज्युकेटर्स आहेत त्या प्लॅटफॉर्मवरती शिकवणारे तुमच्या सर्व शंकांचे निरसन करतील आणि निश्चितच तुम्हाला बोर्डाच्या परीक्षेमध्ये सीईटी मध्ये चांगले मार्क्स मिळतील. यानंतर टेस्ट सिरीज देखील आहेत त्यांच्या. या टेस्ट सिरीज मध्ये देखील तुम्ही भाग घेऊ शकता. या टेस्ट कशा द्यायच्या त्यासाठी देखील त्याचं डिस्क्रिप्शन इथे दिलेलं आहे, ते तुम्ही बघू शकताय. आणि जर समजा तुम्हाला हे सबस्क्रिप्शन घ्यायचं असेल तर तुम्ही माझ्या नावाचा कोड म्हणजे वसंत सर हा अप्लाय करून तुम्ही ते जर घेतलं तर तुम्हाला त्यामध्ये निश्चितच डिस्काउंट मिळेल. Solve the following equations by method of inversion. Now the first example, 2x minus y is equals to minus 2. Second is 3x plus 4y and that's equals to 3. Now we'll solve this. The given equation can be written in matrix form as. Okay, now see this is the given equation. We can write in this matrix form. What is that? See this here. The first equation is a 2x minus y is equals to minus 2 and second is 3x plus 4y is equals to 3. म्हणजे इथे काय लिहिणार आपण? That is a 2 minus 1 3 4. Okay. Next is a variable matrix which is the xy and that's equals to the constant matrix, that is a minus 2 and here is a 3. Okay. Now the value of here a is equals to A is equals to the matrix 2 minus 1 3 4 variable matrix capital X is equals to X Y, and last is the constant matrix capital B is equals to minus 2, and here is a 3. Now again this can be written as, हे आपल्याला असं लिहिता येईल, that is a AX A capital X and that's equals to B. Now we'll pre-multiply on both sides by A inverse. Here I will write here pre-multiply on both sides by A inverse. Pre-multiply. Therefore, I will multiply here, that is the A inverse into A X, that is equals to A inverse into B. Okay. Now what is the A inverse into A? A inverse into A, that is I. Here is I. I is equals to I into X, that is equals to A inverse into B. I into X, that is nothing but this is a capital X, and here is a inverse into B. Now here we want to find out the A inverse. Now to find out the A inverse, we can find out by using the adjoint method or by using the transformation method. Now we'll find out it by using the transformation method. Let us find A inverse. Okay. आता A inverse find out करण्यासाठी, before that we want to find out its determinant. That is, determinant of A is equals to. Now what are its values? Is 2 minus 1 3 4. I will write here 2 minus 1 3 and 4. Okay, its a value is 2 into 4, here is 8, minus 3 into minus 1, that minus will become plus 1. Therefore, I will write here plus 3, 8 plus 3, and that's equals to 11, which is not equals to 0. Therefore, A inverse exists. A inverse exists. Now we'll find out the A inverse. Now consider here A into A inverse, and that's equals to R. We'll write here the value of A. A ची value आपण लिहिते देणार, which is 2 minus 1 3 4, and here is A inverse, and that's equals to 1 0 0 1. आता आपल्याला we'll apply here the row transformation. इथे 1 करायचं, मग काय करता येईल आपल्याला? That is, first of all, my first operation is R12. Then we get R12. Then we get, मग काय लिहिणार इथे? R12. This is 3 4 2 minus 1 into A inverse, and that is equals to 0 1 1 0. What about the next? R1. Next operation is that इथे 1 करणार आहोत आपण, that is by the operation, that is R1 minus R2. We get R1 minus R2. Then we get, I will write here, that is 3 minus 2, you will get 1. 4 minus in bracket minus 1, therefore here you will get 5. Okay. Next, 2 and minus 1, keep it as it is, and here is a inverse. The same operation इकडे आपल्याला perform करायचे. R1 minus R2, that is 0 minus 1, is a minus 1, हा इथे 1 आला. Next 1 and 0, keep it as it is, 1 and 0. Okay. Now the next is, the इथे 2 च्या जागी आपल्याला काय करणार, replace this 2 by, that is a 0. We want to perform the operations. काय करावं लागणार, that is a by R2 minus 2 times R1. Therefore, you will get here 1, 5. Okay. R2 minus 2 times R1. म्हणजे इथे किती झाला? 0 झाला. Minus 1. Okay. Here is a minus 1. 5 into 2. That is a 10. Minus 1 and minus 10. Minus 1 and minus 10. Here you will get minus 11. Same operation on this side also. Here is minus 1, 1. R2 minus 2 times R1. That is the 1. Minus 2 into minus 1. That will become plus 2. And 1 plus 2. Here is a 3. 0 minus, here is a minus 2. Okay. Now the next operation is make this element as a 1. Therefore, I will write here by minus 1 upon 11 R2. Then we get, okay. Then what is that operation? Here is a 1, 5, 0, 1 into A inverse, and that's equals to minus 1, 1, and here is a minus 3 by 11, minus 3 upon 11, and minus 2 up into minus 1 upon 11, that will become 2 upon 11, 2 upon 11. What about the next operation? That is a R2, sorry, by the operation R1 minus 5 times R2. Then we get, here, what is that operation? That is, here we get the identity matrix 1, 0, 0, 1 into A inverse, and that's equals to, okay, that is R1 minus 5 times R2, that is a minus 1. Okay, minus and minus will become plus. 5 into 3, 15. 15 upon 11, that is minus 1 plus 15 upon 11. Then you will get here 4 upon 11. Next is 1 minus 5 into 2, 10. That is 1 minus 10 upon 11. And then you will get here, that is a 1 upon 11. Here is a 1 upon 11. And next is a minus 3 upon 11. And last is a 2 upon 11. And here is a complete. Therefore, now this is the identity matrix, identity into A inverse, that is equals to, here is A inverse, and it is 4 upon 11, 1 upon 11, minus 3 upon 11, and last is a 2 upon 11. Now we'll substitute this value in above equation. That is a x is equals to A inverse into B. Okay, we'll substitute the value, that is x is equals to A inverse into B. I'll write here x is equals to A inverse into B. B is a constant matrix. Okay, therefore here the value is the value of 4 upon 11, 1 upon 11, minus 3 upon 11, and 2 upon 11 is a complete, into the value of the constant matrix B. What is the value of the B? B is a minus 2, 3. Here is a minus 2 and 3. Minus 2 and 3. Okay. Now we'll multiply here. That is a multiplication. First row, first column. That is minus 8 upon 11 and 1 upon 3. Minus, here is a minus 8 upon 11. 4 into 2 minus 8 upon 11 and 1 into 3, that is a 3, plus 3 upon 11. This is the first. What about the second? Minus 3 by 2 into minus 2, that will become 6 upon 11. Here is a 6 upon 11, and next is again the 6 upon 11 plus 6 upon 11, and that's equals to minus 5 upon 11, and here is a 12 upon 11. Therefore, the values of x and y are, these are the values. See this here, the value of x is equals to, what is here, x, y, and it is a minus 5 upon 11 and 12 upon 11. Therefore, by equality of matrices, x is equals to minus 5 upon 11 and y is equals to 12 upon 11. This is the required solution. This is the required solution. Now the next problem is x plus y plus z is equals to 1, 2x plus 3y plus 2z is equals to 2, and third is ax plus ay plus 2az is equals to 4. Therefore, the given equations can be written in the matrix form as, okay, the given equation can be written in the matrix form. See this here. 1, 1, 1, 2, 3, 2, A, next is A, and last is 2A. Okay, this is 1, 1, 1, 2, 3, 2, and A, and next is 2A. Here is a variable matrix X, Y, Z, and last is a constant matrix. It is a 1, 2, and 4. This is the constant matrix. This is of the form. This is of the form. What is that form? A capital X is equals to B, where the value of A in this matrix, X capital X means X, Y, Z, B means the constant matrix. And again, by pre-multiplying on both sides by A inverse, pre-multiply on both sides by A inverse. Therefore, A inverse into AX is equals to A inverse into B. Now, what is the A inverse into A? That is equals to I into X is equals to A inverse B. Therefore, here is a X is equals to A inverse into B. Now, we'll find out here the value of the A inverse. I can write here. We'll write here A into A inverse, and that's equals to A into A inverse, that's equals to I. Okay. Now substitute the value of A. What is A here? A is a 1, 1, 1. Here is a matrix. 1, 1, 1. Next is a 2, 3, and 2. And the last is A, and here is a 2A. Into A inverse, and that's equals to 1, 0, 0, 0, 1, 0, and here is a 0, 0, 1. Okay, this is again we'll find out the inverse of that matrix by using the transformation method. Now, by using the transformation method, there is already one there, that is a R2 minus 2 times R1 and R3 minus A times R1. We get, okay, we get now the first row is as it is 1, 1, 1. What about the second row? That is R2 minus 2 times here is 0. Next is a 1, and again here is a 0. What about here? Again, that is a minus A, 0. Here is a 0. Again A. Yes. Into A inverse. Again, the first row is as it is. Therefore, you will get 1, 0, and 0. R2 minus 2 times R1. That is here is a minus 2. Next is a 1 and 0. R3 minus A times R1. R3 minus A times R1. Therefore, you will have minus A, 0 and 1. Okay. Now the next operation. What is that? इथे ऑलरेडी 1 आहे. फक्त वरचा आपल्याला 1 काय करायचं आहे? तिथे 0 करायचं आहे. Therefore, by using the operation that is a R1 minus R2, we get R1 minus R2, we get that is here. या दोन्ही रोज मात्र कॉन्स्टंट आहेत म्हणजे कुठल्या तर R2 आणि R3 0 1 0 0 0 A. फटाफट here 1 झाला इथे हे 0 झाला and here is a 1 and next is a A inverse या बाजूला देखील या ऑपरेशन that is R1 minus R2, that is 1 minus in bracket minus 2, that will become here is a 3 minus 1 and 0. Next is a minus 2 1 0 minus A 0 1. Keep this as it is. This is okay. What about the last? आता इथे काय करायला पाहिजे आपल्याला तर 1 करायला. Therefore, by 1 upon A R3, then we get here 1 upon A R3, then we get R3 is फक्त बदलणार आहे. Keep these other rows as it is. 1 0 1 0 1 0 and the next is a 0 0 1 into A inverse, and on this side what is that here 3 minus 1 0 minus 2 1 and 0 1 upon A R3. Therefore, here you will get that is the minus 1 will be there, minus 1 होणार इथे and what about here हा zeros असणार आहे and here is a 1 upon A 1 upon A. Okay, this is now what about the last operation? आता इथे आपल्याला हा काय करायचा आहे तर तो 0 करायचा आहे. Therefore, by the operation R1 minus R3, we get R1 minus R3, we get here totally identity matrix. That is 1 0 0 0 1 0 0 0 1. Okay, here is identity into A inverse, that is R1 minus R3, R1 minus R3. Therefore, on this side you will get 3 minus in bracket minus 1, that will become here is a 4. You will get here 4. Next is 1. What about here? R1 minus R3. That is a minus 1 upon A. And the remaining element is as it is, which is the minus 2, 1, 0, minus 1, 0. And here is a 1 upon A. Okay. Here is 1 upon A. Therefore, A inverse. Here is A inverse, that is equals to A inverse is equals to 4 1 minus 1 upon A. Next is a minus 2 1 and 0, minus 1 0, and last is 1 upon A. This is the A inverse. Now see this here, that is a capital X is equals to A inverse into B. Now we'll substitute the value of A inverse here, right here. Therefore, capital X, the value of capital X, that is equals to 4 minus 1 upon A. Here is a minus 1. Let's take out it into the plus 1. Okay. Now A inverse, that is the 4 minus 1 minus 1 upon A. Next is a minus 2, 1, 0. And what about the last row, which is the minus 1, 0 and 1 upon 8. Minus 1, 0 and here is a 1 upon 8. Okay. Now the constant matrix, which is 1, 2 and 4. Here is a 1 to 4. Now we'll solve this. Therefore, here is their multiplication. Here is the first row and this column. 4 into 1, 4, minus 2 and minus 4 upon 8. 4 minus 2 minus 4 upon 8. Next is the second row and this column. Minus 2, 2 and 0. Minus 2 plus 2 and last is a 0. And last is minus 1, 0 and 4 upon A. There is a minus plus 0 and plus 4 upon A. Here is a 4 upon A. And okay, now we'll solve this. That is a 4 minus 2. That is a 2 minus 4 upon A. This is the first. Plus 2 minus 2. That is a 0 here. Minus 1. That is a 4 upon A. 4 upon A minus 1. Therefore, the value of this capital X is equals to, सर्व ते A मुळे fraction मध्ये आलं, due to the value of A, 4 upon A, there is a 0 and last is a 4 upon A minus 1. Therefore, what is that? This is nothing but the values are here is X, Y and Z. Therefore, by equality of matrices, by equality of matrices, the value of X is equals to 2 minus 4 upon A. This is the first one. The value of Y, that's equals to 0 and Z is equals to 4 upon A minus 1. 4 upon A minus 1. Now the next problem is 5x minus y plus 4z is equals to 5. 2x plus 3y plus 5z is equals to 2. And last equation is 5z minus 2y plus, here is a, instead of 5z we can take here, that is a 5x minus 2y plus 6z is equals to minus 1. Now the solution is the given equation given equations can be written in the matrix form as the given equation can be written as in the matrix form. You see this here. The first is 5 minus 1 and 4. 5 minus 1, 4. Second is 2, 3, 5. 2, 3, 5. And last is 5 minus 2, 6. 5 minus 2, 6. And here is a constant matrix X, Y, variable matrix, sorry, and constant matrix, that is a 5, 2, minus 1. It's 5, 2, minus 1. This is of the form, A x is equals to b. Okay, Ax is equals to b, where capital A is equals to what is that? The matrix 5 minus 1, 4, 2, 3, 5, and 5 minus 2, and here is a 6. Okay. Next is a variable matrix, which is denoted by the capital X. Small x, small 1. And last is a constant matrix. Capital B is equals to 5, 2, minus 1. Okay, 5, 2, minus 1. Now again, it is of the form, that is A x is equals to b. Pre-multiplying on both sides by A inverse. Pre-multiply on both sides by A inverse. Therefore, pre-multiplying on both sides by A inverse, we can write here A inverse into A into X is equals to A inverse into B. Therefore, X is equals to A inverse B. Okay. Now we'll find out the A inverse by using the transformation method. त्या मेथडने आपण A inverse find out करूया. Therefore, I will write here A into A inverse, that is equals to I. The value of A is 5 minus 1, 4, 2, 3, 5, 5 minus 2, and here is a 6. Okay. Next, here is a into A inverse, and that's equals to I 1 0 0 0 1 0. Now the first operation, that is a R1 minus 2 times R2. Then we get R1 minus 2 times R2. Then we get, here is a 5 minus 4, that is 1, minus 1. Next is a minus 1, 3 into 2, that will become minus 6, minus 1 minus 6, and here we have the minus 7. 4 minus 5 into 10, that is a 4 minus 10. Therefore, here is a minus 6. And next, keep second and third row as it is. That is a 2, 3, 5, 5, minus 2, 6 into A inverse. What about here? That is R1 minus 2 times R2. 1 minus 2, 0, 0, 1, 0, 0, 0, 1. Okay. Now the next operation, we can make this 0 and 0 by using, that is by R2 minus 2 times R1 and R3 minus 5 times R1. Okay, the first is 1 minus 7 and minus 6. R2 minus 2 times R1. This will become 0. Next is a 3. 7 into 2. Minus 7 into minus 2. That will be 14. 3 plus 14. That is, here is a 17. What about here? 5. 2 into 6. 12. 5 plus 12. Here is a 17. What about the last row? That is R3 minus 5 times R1. This element will become 0. What about here? Minus 2. Minus 2 minus 5 into 7. That will become plus 35. Minus 2 and plus 35. Minus 2 and plus 35. That is, here is a 33. What about the last? It's a 6 minus. That minus and minus will become plus. 5 into 6, that is a 30. And here is again 6. Therefore, we will get 36. On this side, that is A inverse. The operation, that is a 1 minus 2, 0. That is R2 minus 2 times R1. R2 minus 2 times R1. Here you will get minus 2. 1 minus, and that will become plus 4. 2 into 2, 4. 1 plus 4. You will get here 5, 0. What about the last? R3 minus 5 times R1. R3 minus 5 times R1. Therefore, here you will get minus 5, 0. Minus 5 into minus 2. That will become 10. And 1. There is a 1. Okay. Now the next is, the next operation, that is a by 1 upon 17 R2. Therefore, you will get here 1 minus 7 minus 6, 0, 1, 1. Here is a 33 and 36. into A inverse, and that's equals to, okay, 1 minus 2, 0. 1 upon 17, that is a minus 2 upon 17, 5 upon 17, and last is a 0. Last row is as it is, minus 5, 10 and 1. Okay, now we can make these two elements as a 0. What is that operation? That is the R1 plus 7 times R2 and R3 minus 33 times R2. Therefore, we get here, that is the first is 1, next is a 0. R1 minus 6. Okay, here is a minus 6 and plus 7. Minus 6 plus 7, then you will get 1. Middle row is as it is, second row 0, 1 and 1. What about the last? Here is a 0. Again here is a 0. That is R3 minus 33 times. Then for you will get here 36 minus 33. There is a 3 into A inverse and on this side. Now the next is second row as it is, that is a minus 2 upon 17, 5 upon 17 and last is a 0. What is the first? R1 plus 7 times R2, that is 1 plus 2 into 7, that is a 14. Therefore, here you will get 3 upon 17. What about the next? Minus 2. Okay. Next, 5 into 7, 35. And 17 into 2, minus 34. Therefore, you will get here 1 upon 17. And what about the last here is a, keep this as it is. Now the next, R3 minus 33 times R2. R3 minus 33 times R2. Okay. Therefore, this is the 33. 33 into 2, that will become plus 66 upon 17 minus 5 plus 66 upon 17. Then you will get minus 19 upon 17. Next is a minus 33 into 5. Therefore, you will get 165 upon 17 and 10 plus 165 upon 17 minus 1. 10 minus 165 upon 17. Then you will get 5 upon 17. Last is a last element that will be remain as it is and not 0. Here is a 1. Keep it as it is a 1. Okay. Now the next operation, that is 1 upon 3 R3. Therefore, you will get here 1, 0, 1, 0, 1, 1 into A inverse, and here is 1 by 3 R3, that is other rows are as it is. Upon 17, 0. What about here? 1 by 3. Okay. 1 upon 3 R3. Therefore, here you will get minus 19 upon 51, 5 upon 51, and last is a 1 by 3. Now the next operation is, what is that? R1 minus R3 and R2 minus R3. Then here you will get the identity. I am writing that is I into A inverse, and this is important now. R1 minus R3. This is R1 minus R3. That is a 3 upon 17. Minus minus will become plus. Again, this can be written as, that is a inverse is equals to, that is a 1 upon 51, and we'll write here 28 minus 2 minus 17. That is multiplied n and d by 17, then you will get this. Next is a 13, 10, again minus 17, and last is minus 19, 5, and again here is a 17. This is the A inverse. Now next we will multiply it with the constant matrix. Okay, therefore here we will have, therefore capital X is equals to A inverse into B, and here is the value of A inverse, sorry, here is a 1 upon 51, and the matrix is 28 minus 2 minus 17, 13, 10 minus 17, minus 19, 5 and 17. The value of B matrix is 5, 2 and minus 1. We'll check it. 5, 2 minus 1. It is a 5, 2 minus 1. Therefore, now they are multiplication. Okay. Now we will multiply here. That is 1 upon, here is a 51. Now this first row and this is the column. 28 into 5, that will be the 140, minus 2 into 2, that is a minus 4, minus 17 and minus 1, that will become plus 17. Second row, again this column, 13 into this 5, therefore you will get 65, 10 into 2, that is a plus 20, and minus 17 and minus 1, that will become plus 17, minus 19 into minus 5, minus 95, here is a 10, that is a 2 into 5, 10, and last is a minus 17, and here you will get 1 upon 51, here sum, that is a 17, 140 minus 4, 136, 136 plus, again here is a 17, therefore you will get 153. What about the next? 65, 75, 85 and 102. Okay. And what about the last? Minus 95. And here is a 85, minus 85 minus 17. That is a minus 102. Minus 102. And now we will divide it by 1 upon, multiplied with 1 upon 151 into 153. Therefore, we will get here 3, 2 and minus 2. Okay, therefore the value of capital X, that is a variable matrix X, Y, Z, that is equals to 3, 2 and minus 2. Therefore, by equality of matrices, X is equals to 3, Y is equals to 2 and Z is equals to minus 2 is the required solution. Is the required solution. Now the next problem is, that is a 2x plus 3y is equals to minus 5, and next is a 3x plus y is equals to 3. Okay, now the solution. Now this can be again written. The given equation can be written in matrix form as. Now can write these equations in the matrix form. That is a 2, 3. Next is a 3, 1. Here is a variable matrix X, Y. That is equals to minus 5 and here is 3. Okay. Now next, this is of the form capital AX is equals to B, where A is equals to coefficient matrix 2, 3, 3, 1. What about the capital X? Capital X is equals to X, Y, and last is a B, which is the constant matrix minus 5 and 3. Okay, now let us find out the value of A inverse. Okay, we can write here. Let us find A inverse. Okay, now we can write here A into A inverse, and that's equals to R. Okay, therefore that matrix or matrix is a 2, 3, 3, 1. 2, 3, and here is a 3, 1. Okay. Into A inverse, and that's equals to 1, 0, 0, 1. Now the first operation, that is R12. By the operation R12, we get, okay, this is the R12, 3, 1, 2, and 3 into A inverse, and next is a 0, 1, 1, 0. Okay. What about the next operation? That is a by R1 minus R2, R1 minus R2, we get R1 minus R2, we get, that is 3 minus 2, here is 1. 1 minus 3, that is a minus 2, and 2, and here is a 3, into A inverse, and that's equals to R1 minus R2, R1 minus R2, you will get a 1, here is a 1, 1, and 0. What about the next? Next is a by R2 minus 2 times R1, we get R2 minus 2 times R1, we get 1 minus 2, 0. Here is a 3. 3 minus 2 into 2, that will become 4. That is plus 4. That is a 3 plus 4, that will become 7. That is R2 minus 2 times. Here is a A inverse. And here is a minus 1, 1. R2 minus 2 times R1, 1. Minus 1 into, that's minus, that will become plus. 1 plus 2, here is a 3. 0, again minus 2. Okay. Now the next is by 1 upon 7 R2. 1 upon 7 R2, we get here, see, 1 minus 2, 0, and 1 into A inverse, and here is a minus 1, 1. 1 upon 7, that is a 3 upon 7 minus 2 upon 7. Okay, that is it. Next operation is a by R1 plus 2 times R2. R1 plus 2 times R2. Therefore, here you will get the 1, 0, 0, 1 into A inverse. What about here? R1 plus 2 times R2. R1 is a minus 1. 2 into 3, that will become 6. That is minus 1 plus 6 upon 7, that is a minus 7, and then you will get minus 1 upon 7. What about here? 1 minus 2 into 2, 4. That is 1 minus 4 upon 7. Therefore, you will get here 3 upon 7, and here is a 3 upon 7 minus 2 upon 7. This is the Okay. Therefore, identity, therefore A inverse is equals to. Now from this we can take 1 upon 7 as a common, and then you will get minus 1, 3, next is a 3 and minus 2. Okay. And therefore here again, that is the x is equals to A inverse into B. The value of A inverse, that is equals to the A inverse 1 upon 7 and minus 1, 3, 3, minus 2. The value of B, what is the B here? B is minus 5, 3. Here, I have right here, minus 5, 3. Now their multiplication, minus 5, okay, minus 5, and here is a 9. Minus 1 into minus 5, that will become 5. 3 into 3, 9. Therefore, the multiplication is 1 upon 7, 5 plus 9. Next is minus 15 and minus 6. Minus 15 and minus 6, and overall you will get 1 upon 7. Here is a 40 minus 21, and you will get the value is a 2 and minus 3. Therefore, the capital X, which is equals to X and Y, that is equals to 2 minus 3. Therefore, by equality of matrices, X is equals to 2 and Y is equals to minus 3 is the required solution. Required solution. Okay. Now the next problem is x plus y plus z is equals to minus 1, y plus z is equals to 2, and x plus y minus z is equals to 3. Therefore, the given equations can be written in the matrix form as given equation can be written in the matrix form as, what is that? The first is, see these equations. 1, 1, 1. X is not present there, therefore 0, 1, 1, and last is 1, 1, minus 1. Variable matrix X, Y, Z, and last is a constant matrix, which is the minus 1, 2, and 3. Okay. Now this is of the form what is that? Ax is equals to b, and then what is the value of a? Where a is equals to this is the matrix, which is the 1 1 1 0 1 1 1 1 minus 1. This is the A matrix. The value of X matrix, which is the variable matrix, which is X, Y, Z, and last is a B, constant matrix, -1, 2, and here is a 3. Okay. Now we'll find out the A inverse, that is a capital AX is equals to B, pre-multiply on both sides by A inverse. Therefore, A inverse into A, X is equals to A inverse B. Now here A inverse into A, that is I, X is equals to A inverse B. Therefore, X is equals to A inverse into B. Okay, this is. Now we'll find out the value of the A inverse. I will write here A into A inverse, that is equals to I. Now here is I. I means what? 1 1 1. A means that is 0 1 1 1 1 and -1 into A inverse, and here is identity, that is a 1 0 0. Now here is a 1. What is the first operation? That is a R3 minus by R3 minus R1. We get R3 minus R1. We get. Keep these two rows as it is. That is the first and second. 1 1 1 1. Next is a 0 1 1. R3 minus R1. There is a 0. Next will be also 0. And last is a -2. Bracket complete into A inverse and 1 0 0 0 1 0. R3 minus R1. Therefore, you will get -1 0 and 1. Okay. Now the next operation is, that is a R1 minus R2 by R1 minus R2. R1 minus R2. Okay. We get by R1 minus R2. We get here R1 minus R2. Other two rows are as it is. R1 minus R2. Here is a 1 0 and 0 into A inverse, and that is equals to 1 0 minus 1, 0 and 1. R1 minus R2. That is R1 minus R2. That is 1 minus 1 and 0. Okay. Now the next operation is here is a minus 2. And we will make it as a plus by minus 1 upon 2. Here is a R3. Therefore, keep this other row as it is. That is 1, 0, 0, 0, 1, 1 and 0, 0. Here is a 1 into A inverse. And next to the 1 minus 1. 0, 0, 1, 0. And what about the last? Therefore, here is a 1 upon 2. Okay, 0 and minus 1 upon 2. Now the next operation is by R2 minus R3 we get, okay, R2 minus R3 we get here. We'll get here identity, therefore I am writing only that I into A inverse. R2 minus R3. Therefore 1 minus 1, 0. Keep this as it is. And next is R2 minus R3. That is a minus 1 upon 2. Okay, here is a 1 and last is a plus 1 upon 2. Now the next is, therefore A inverse is equals to, here is a 1 minus 1, 0, minus 1 upon 2, 1, 1 upon 2, 1 upon 2, 0, minus 1 upon 2. Now we substitute here the values here. That is a x is equals to A inverse into B. तो अपन की value substitute करना here, value right here. X is equals to A inverse into B, and here is the value. Therefore, right here, x is equals to 1 minus 1, 0, minus 1 upon 2, 1, and here is a 1 upon 2, 1 upon 2, 0, minus 1 upon 2, bracket complete, into the constant matrix. What is the constant matrix? The constant matrix is a minus 1, 2, 3. I will write here minus 1, 2 and 3. Okay. Now here is the constant matrix. The first row and this column, that is the first is minus 1, minus 2 and last is 0. What about the next? 1 upon 2. That is minus 1 upon 2 into minus 1. 1 upon 2. 1 into 2. That is a plus 2. And next is a 1 by 2 into 3. Therefore you will get plus. Here is a 3 upon 2. What about the last? Minus 1 upon 2. 0 and minus 3 by 2. Minus 1 upon 2, 0, and here is a minus 3 by 2. And overall, you will get here 1 minus 2, and that is a minus 3. Here is a minus 3. 1 by 2 plus 3 by 2, that is a 2. 4 by 2, that is a 2 plus 2. Overall, you will get here 4. Minus 1 upon 2 minus 3 by 2 minus 4 by 2, and that is a minus 2 is here. Therefore, again here we will write here that is a capital X is equals to the variable matrix, which is X, Y, and Z, and that's equals to minus 3, 4, and minus 2. Therefore, by equality, of the matrices X is equals to minus 3, Y is equals to 4, Z is equals to minus 2 is the required solution. This is the required solution, and in this way we have completed this question. I will see in the next video. Goodbye.